We're going to hear now about how big data is used to aid business and keep all of us safe in the skies from National Air Traffic Systems. Would you please welcome Simon Daykin.
Good afternoon. So my name is Simon Daykin. I'm from NATS, which was formerly the National Air Traffic Service. We are now a part privatised organisation, and we are responsible for the airspace above the UK. We also look after a lot of the air traffic services at a number of airports, both in the UK and as the markets deregulate elsewhere in the world. So what I'm going to talk to you today is about how information technology, information sharing, big data is really changing the opportunities we have as an organisation to deliver a completely different service to our customers, who actually, at the end of the day, is everybody in this room. If you fly, you're using our services, and you often may not see it and feel it. You may not use our app because you're not piloting a plane yourself, but actually you're benefiting from the information technology and the use of big data we have. So my aim today is just to give you an insight of what some of that is and some of the real capabilities that you can exploit in this new paradigm, but also from a commercial perspective, the partnerships and the new kind of capabilities, the new people coming to the market that are making a real difference, because some of our most transformational partners are now small businesses, and particularly in the UK. So first of all, just to give you an idea of who we are. So we're a service provider for air traffic management. One of the advantages we have now in a deregulated market is taking that to the world. So we are delivering air traffic management services elsewhere in the world as well. We're the leading air traffic management provider. We handle about 2.1 million flights per year. That's just in UK airspace. And we provide a service 24 hours a day, 365 days a year. For the techies in the room, this is actually one of the biggest challenges, because you cannot turn off the air traffic management system. There are planes in the sky every hour, every day. And if we want to do a system upgrade, if we want to put new technology in, we have to maintain complete and total continuity of safe service, which brings a whole new set of challenges, a whole new set of capabilities with that too. Just to give you an idea of what that looks like in terms of airspace as well, the airspace is broken up into parts called flight information regions. In the UK, we have two areas, the London and the Scottish areas, and in the UK, we're also responsible for the top right-hand corner of the North Atlantic Ocean. Just taking the domestic airspace, we're responsible for 11% of Europe's airspace, but actually 25% of Europe's traffic. So what we have is some of the most congested skies in the UK, and the invisible infrastructure that sits above us that enables you to get from airport to airport is fundamental to the performance and the experience you have as a customer. The Shanwick Oceanic Centre as well handles about 80% of the traffic to or from the US, because nearly all the traffic from Europe passes through that area to get to the other half of the ocean managed by the Canadians. Now, the best way to really experience this is through a visualization we made. And this is where we've taken a very large data set and compressed it into 2 minutes. So if we start the video, this should give you an idea of what a day in Europe looks like in terms of traffic passing around our skies. So the video starts and you'll see the traffic coming over from the US. So it's early morning, Europe has already woken up, but you'll see that rush of inbound traffic, thousands of flights coming from the US, following tracks in the sky, roads in the sky, because over the ocean, we don't have the ability to know where the traffic is, so we have to safely separate it based on keeping them apart and on the same routes. You can see here the highways that emerge in the sky through the airspace structures we have today, and how the flights have to work together and make sure that they are safely separated from each other at all times. You'll see, particularly in a minute, over North Wales, where we have military traffic, military flights on training missions and sorties, coexisting with commercial flights, and particularly in the southeast of England, the busiest airspace in the world. We have a very closely knit sequences of arrivals and departures from some of the busiest airports in the world. Gatwick, down on the bottom of the screen, is the busiest single runway airport in the world, and Heathrow is the busiest dual runway airport in the world. So what you can see here is not only a huge amount of information, but actually a huge amount of decisions being made in real time by many actors across many systems, the pilots, the controllers, the airlines managing their flows and traffic, and us as paying customers wanting the best experience. Because we don't see this on a day-to-day basis. What we as customers of the airline see is an experience of whether we leave the gate on time, whether we arrive on time, and how often do you hear air traffic control as the excuse for when you don't actually meet the runway on time. Again, you'll see the traffic leaving at the end of the day towards the US, and it all starts again. So that's about 6,000 or 7,000 flights every day just over the UK and over Europe. And one of the difficulties and the challenges we have is joining that up as a system. So it may surprise you to know is today, all of Europe is broken out into these flight information regions, and other than coordination messages, there is very little in terms of long-term planning of how flights move between different parts of the airspace. So what does that mean? Well, that means, for example, if you come into a flight at Heathrow, many of you would have experienced going round in stacks, circling the airfield, waiting for a time to land. So one of the big changes that we're making is sharing information with other people. So we've created a capability where actually now we are sharing what the live arrival sequence at Heathrow looks like out to our partners up to 500 miles in advance, so that we can start to give our partners a much clearer view of when the best time to arrive at Heathrow is. And that allows us to carefully balance two competing factors. We need the planes to be at Heathrow and on time to make sure that we keep the pressure up on an airport that is operating at pretty much capacity. On the other hand, we don't want people going around in stacks because that uses huge amounts of fuel. That means a lot of CO2 emissions, and it's a bad experience for customers. So where we're moving to is actually sharing information with partners nearby to extend the flight time if there is delay. So reducing the speed further out, up to 500 nautical miles away from Heathrow, reducing the speed so actually as the plane enters our airspace, it's already on a slow, graceful and very efficient arrival into Heathrow, and there is no going around in circles. So we're sharing this real-time information with partners across the world to jointly change the experience we have for our customers. The interesting thing about this is this has been delivered through a very small organisation based in Southampton that are able to help us with these new technologies, because actually the technology is not the hard bit these days. It's about integrating the concepts and the different ways of working. And one of the benefits we have as an industry is a set of open standards, a set of future standards of how we're going to interoperate together, which has enabled small organisations to come up with highly innovative solutions, such as this, that are making millions of pounds worth of savings to our customers and a much better experience for the end users. So this is just one example of how information sharing amongst organisations that didn't even used to share information is really transforming the way people work. Another example I'll talk about, and this is where we really get into much bigger data sets and much more real-time data. And for me, big data is not just about the scale of data, it's about the speed at which you can use data and the velocity at which you can make better decisions that really impacts performance. So talked about earlier on in terms of how important the arrival rate is at airports like Heathrow, airports operating at very near capacity. If you can't get planes on and off the ground, then you've got passengers sitting around getting quite irate. And on a normal day, planes landing at Heathrow, we land between 40 and 50 aircraft per hour at Heathrow, and that's based on a number of factors, particularly, and some of you may be aware of this, planes create a wake behind them called a wake vortex, and we have to make sure the planes are separated based on their weight. So you'll often see big planes coming in together and small planes coming in together, and we have a very well-crafted operation that ensures that the planes arrive on time, in sequence, and are safely separated as we come into land. The challenge we have is headwinds. So today, the biggest single cause of delay at Heathrow is strong headwinds. This is something we have absolutely no control over. Headwinds mean that the wind at which the flight is heading into is slowing. The plane is already at the same speed. It's covering the same speed over the ground. But because we have to keep the distance between the aircraft the same, because we have to keep the weight, because of the size of the aircraft and the weight vortex, because traditionally we have to keep them separated by the distance, our landing rate reduces dramatically. We go down to about 32 to 38 aircraft movements per hour, which has a dramatic impact on the service that the customers get. So as the headwinds go up, our performance goes down. So what we've done is try and find a way of solving this problem using the vast amount of information we have. So we bring together huge amounts of information. So we have real wake vortex measurements. We've used special equipment called LiDAR, which looks at the air behind an aircraft as they're coming into land. We have over 100,000 recorded deliverables of aircraft landing to actually get a clear view of, in different wind circumstances, how quickly that wake vortex dissipates. So we know when the wind is higher, actually the wind will dissipate much quicker. We also have this live sequence data we touched on earlier on, making sure we know what flights need to arrive in what order and what the best way of sequencing those flights are, so we get the big planes and the little planes in the right order. The really innovative bit as well is we're taking live downlink data from the aircraft itself. So from the aircraft, we are taking live information in real time from every aircraft coming in with exactly what it is experiencing at that point of time. And by bringing those together, we create an engine, which means we can dynamically decide how far apart those planes need to be. This then gives us the tools we can give to our controllers to actually say, rather than separating our planes based on the traditional distance, we can actually separate our planes based on how safely they can be together based on time rather than distance. And this is where we get to a model called time-based separation. So time-based separation is actually separating the planes based on how far they need to be apart in time rather than distance, which means we can improve the landing rate very significantly. Because when they're flying into headwinds, because we now know directly from the plane what wind speed it's encountering, because we know how quickly the wake vortexes dissipate, because we know the sequence order, we can bring all of that information together in real time and give the controllers the ability to actually keep the planes as close as they safely can be and increase the landing rate. So this is an example of how you can bring together huge amounts of information, but not just scale in time as well, to really improve the experience you can have for the customers. And some of our biggest, some of the very important innovators we have in this market are relatively small organizations that are able to grow and help us on this journey quite quickly. So just to conclude quickly, sharing information and collaborating across industries brings both business and customer benefits. Everything I've talked about today is about bringing benefits to our end customers, but actually that drives our business benefit as well, because if we deliver a better experience for our customers, they get a better experience, they give a better experience to their customers, and actually that's all down to information sharing. Where we used to control the information we shared, these days we share it much more freely. Big data is not just about large data sets. Again, this is also about the velocity of information and some of the real-time information you have access to. And finally, the democratization of information. So this is what I was touching on in terms of, as more information is made available, as information sets are opened up, all of you can go and access live information from apps on your iPhones in terms of where aircraft are. This is giving small organizations new opportunities to help fix big problems that have big impacts on customers, like the ones I've shown today. So hopefully that's just given you a short kind of introduction and ideas into some of the ways that big data, live data, really fast data can have a massive impact on customers and bring new business opportunities. Thank you.